Hello everyone and welcome to Machine Learning and Large Language Model tutorials. In this tutorial, we explain how to install and run a distilled version of DeepSeek-R1 AI model in Python on Raspberry Pi and Linux Ubuntu. For those of you who are not familiar with DeepSeek-R1, here is a brief introduction. DeepSeek-R1 is maybe one of the most powerful AI reasoning models whose performance is similar to the ChatGPT models and performance of state-of-the-art large language models. However, DeepSeek-R1 is released under the MIT license. This means that you can use DeepSeek-R1 for commercial purposes. That is, you can freely integrate it in your application, in your project, and you can sell the app or commercial software. In this tutorial, we are running a distilled version of DeepSeek-R1 model completely offline on Raspberry Pi. That is, we have downloaded and installed DeepSeek-R1 locally. The local installation enables you to speed up the design process, it enables you better privacy, it enables you complete control of large language model behavior and integration in other software. Due to the limited computational resources of Raspberry Pi 5, we will download and install distilled versions of DeepSeek-R1. Distilled versions are obtained from the original version of DeepSeek by reducing the size of the model. Of course, by reducing the size, the performance of the model is reduced. However, often this reduction in performance is not significant and the model can still be very useful. Our Raspberry Pi has the following specifications. We are using Raspberry Pi 5 with 8 GB RAM, 512 GB of SSD NVMe disk. Namely, we have integrated an SSD disk with Raspberry Pi, and this significantly improves the read and write performance of Raspberry Pi and enables us to quickly load and write files to our Raspberry Pi, as well as to read files from our disk. Then, we are running Linux Ubuntu 24.04. Our suggestion is to install Linux Ubuntu instead of the official Raspberry Pi operating system. The reason for that is that Linux Ubuntu has much better support. Furthermore, you can use robot operating system, computer vision, and other algorithms in Linux Ubuntu 24.04. I have created 2 video tutorials explaining how to integrate a solid-state drive with Raspberry Pi and how to install Linux Ubuntu on Raspberry Pi 5. The material explained in this tutorial can serve as the basis for integrating DeepSeek-R1 in robotics, computer vision, and mechatronics projects. We have created several video tutorials on how to install ROS, computer vision, and similar models and algorithms on Raspberry Pi 5. Then, if you're using these algorithms as well as large language model or a visual language model, you can obtain a very powerful computational and AI platform for development of robotic systems as well as for rapid prototyping. Okay, let's start with explanations and with installation. The first step is to open a terminal. Click here and search for terminal. And before I start with explanations, I need to mention the following. Since I'm recording this video by using Kazam, I'm using my Raspberry Pi 5 resources. Consequently, the execution of some commands might be slower compared to the execution that you will experience. Namely, since I'm recording, the processor is being slowed, and then consequently, the execution might be slower. Okay, however, this will not happen in your case. First of all, whenever you want to install a program or a software on Linux Ubuntu or Raspberry Pi 5, always run sudo apt update and sudo apt upgrade. This is going to update and upgrade all the software packages. So be patient. If you didn't execute this command for several weeks, then it might even take a few minutes to complete this command. The next step is to install curl. To install curl, simply execute this command. After you execute this command, type curl -- version to double check the curl version that you're currently running. And if curl is installed, you will see this version. Next, we need to allow inbound connections to this port. Don't worry, here you're not opening the port to external entities or to external computers outside of your local network. You're just enabling a program that will run DeepSeek to connect to the local port of your computer. In this video tutorial, we are going to use Ollama to download the model. Consequently, go to the Ollama website, here it is, and if you cannot see the name of the website over here, here's the name of the website. It's simply ollama.com. So go over here, then click on download, and click on Linux, and click over here, that is copy this command, go back to the command prompt, and inside of this command prompt, execute this command. This command will execute this script install.sh, and it's going to download and install Ollama. For those of you who are not familiar with Ollama, Ollama is a very powerful framework for running large language models locally. You can simply run the model by using command line. However, in this video tutorial, we are not going to use command line. We will use Ollama as a backend for running the model in Python, and I will explain that later on. So let's run this command, and this command will download and install Ollama. After Ollama is installed, you will see this message: no NVIDIA AMD GPU detected. Don't worry about it, since we will be running our model on CPU, and you don't need actually a GPU to run a small model. Okay, the next step is actually to download the model. For that purpose, go back to the Ollama website, and over here search for models and search for DeepSeek-R1. And let's explain what's written over here. Namely, if you click here, you will obtain a list of available distilled models. As I mentioned previously, these are not full models. They are reduced size models. However, their performance is still good. In fact, very similar to ChatGPT Mini. Okay, so in this video tutorial, in order to boost the download process, that is to speed up the download process, I'm going to download this smaller model. I tested this small model, 7B model, 8B model, and they work with good speed. That is, the inference speed is not too slow. However, 14B model, already there, the inference speed is relatively slow. So I suggest to everyone to consider one of these three models. In my case, I'm going to click on 1.5B model, and its size is 1.51 gigabyte. So click here, and this installation command will be generated. I'm not going to immediately execute this installation command. I'm going to replace run by pool. This is because if you just run this command like this, the model will be downloaded and automatically executed, and we don't want that. I just want to download the model, and then I will explain you how to run it later on. This is very instructive and good to learn. So paste here command, and then over here, instead of run, type pool and press enter. And now the model is being downloaded, and you can see over here that it takes around 1.5 minutes to download the complete model. After we downloaded the model, let's learn how to run it. First of all, let's type Ollama list to list all the models. Here it is. And let's run the model. To run the model, copy the name of the model and type Ollama run and then the name of the model. Here it is. Press enter, and now you have to wait for a while for the model to load itself. You can see how quickly it is to load the model, and now I'm going to ask the question: how to solve a quadratic equation? And let's write a quadratic equation, for example this one. Now when I press enter, the model will be executed, and the model will try to provide the answer to this question. And you might see that the speed of the model is not great. This is mainly because I'm slowing down the model execution because I'm recording this video. However, in your case, the execution speed will be much better. And you can see over here what's happening. Let's wait until the model is being called, and here it is. To solve the quadratic equation, blah, blah, blah. And you can see it furthermore, what's happening. I'm just going to stop recording this video for a second for the model to load everything quicker, and then I will show you after 5 or 10 seconds what happened. And over here you can see after maybe 30 seconds what happened. You can see that the response is generated, and over here you can see even the formulas, etc. Good. This means that we can run the model, and let's continue further. The next step is to create a Python virtual environment and to write a Python script that will call the model from Python. Now I press Ctrl C to stop the model. To exit Ollama, press Ctrl D, and that's it. First, let's verify that Python is installed on our system. To do that, let's type which Python 3, and if Python is installed on your system, you should get this path to the Python binaries. Now, you don't need to install Python on your system. Namely, if you install Linux Ubuntu, a certain version of Python will come together with your Linux Ubuntu installation. To see your current Python version, you need to execute this command over here. So let's see what's the current Python version on my computer. It's 3.12.3, and that's precisely the Python version that comes together with Linux Ubuntu 24.04. Good. Next, let's create a workspace folder for our Python virtual environment. First of all, let's go to the home folder. So in the home folder, let's create a folder called test model. Let's navigate to the test model. And inside of this test model, we are going to create a Python virtual environment. First of all, let's make sure that the command for creating Python virtual environment is installed on our system. To do that, execute this command. And it's already installed. That's good. So let's create the Python virtual environment. To create the Python virtual environment, we need to execute this command. Let's explain this command. Here we are calling Python, then we're specifying -m option. We are calling venv, meaning that we want to create a Python virtual environment, and here's the name of the Python virtual environment, bang. Now it's going to take a while to create the Python virtual environment. Let's be patient, and let's type this command to see the folder in which the configuration files of the Python virtual environments are stored. Next, we need to activate the Python virtual environment. We do it like this. Good. Now over here you can see that the Python virtual environment is active. The only library that we need to have to run a Python script is the Ollama library. This is a Ollama Python interface which will enable us to call Ollama from our Python interpreter. That is from our Python code. And finally, let's create our Python script. Inside of this virtual environment, I'm going to create a file called test.py. I'm using the Nano editor. However, you can also use any other editor. Nano editor should come together with Python, and here it is. Here, to save time, I'm simply going to copy and paste the file. First of all, we need to import Ollama. The next step is to specify the model name. And over here, I'm going to erase this model name. Let me just go here. And I will enter the correct model name. How to find the correct model name? Well, let's open a new session of terminal. And in this new session, let's type Ollama list, and you can see the name of the model. So I will copy this, then I will go to this original terminal, and I'm going to paste the name of the model. Good. It's DeepSeek-R1 1.5b. And here's the question that I want to ask: how to solve a quadratic equation. Here, I need to call ollama.chat. That is, I'm calling the Ollama Python API. I'm calling the function chat. I'm specifying the model name, and I'm specifying the message. This list over here contains this dictionary over here where I'm specifying the role. That's your role. Your role is the user. The content is question to ask. That's the question you want to ask. And that's it. Here, Ollama.chat will be called, the question will be passed, and the response will be stored in this data structure called response. To extract the actual response, you need to write this response, then message content, and this string Ollama response will contain the response. Then over here, I'm going to print the response on the computer screen, and at the same time, I'm going to save the response in this file called output-ollama.txt. I'm going to save it. That is, I'm going to open, first of all, this file in the write mode. I'm going to specify the encoding UTF-8, and why I'm using with open. Namely, with open enables you to open a file without worrying what will happen if, for example, your code breaks due to some error. With open will make sure that the file is properly being saved. This is very important, as well as, first of all, saved, then closed. Inside of this with open, we are simply typing write, and we are typing what to write. We simply want to write the response. That's it. Simple as that. Let's save this file by pressing Ctrl S, or you can also press Ctrl O, press Enter, press Ctrl X to exit, and let's execute this file over here. Again, the execution of this file might be slower since I'm recording this video. So let's type now ls-la to see the file, and to execute this file you simply need to type this .py and bang. Now you have to wait for the file to be created, and the response will be written on the computer screen. If you open a monitor, namely you can open monitor by clicking here, then searching for monitor, you can monitor your CPU usage. You can see that all 4 CPUs are used with 100%, and you can see what's happening. You can see the memory over here. You can see that the memory is used, let's say 75%, and you can see that swap memory is also being used. Good. So let's wait until the model generates the response. And that's it. After approximately a minute or two, the response is completely generated. Here it is. Then let's see the file. Let's go to the home folder. Let's go to the workspace folder where it is. Let me just see it. Test model, here it is. Let's go to the file. Here it is. Let's click on the file, and bang, here's our response. Looks beautiful. Looks amazing. Here's the response. You can play with this response, you can include it in your report, or you can just study from it. Okay, that's all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons, and see you in the next video tutorial.